Hi, this is Boshi. Today I want to talk about the second question of homework 11. So for the second question of homework 11, they give us three functions, and they want us to find out if they represent an autocorrelation function of WSS stochastic process and if they are a spectrum density function. So for the first one, which is Fw equal e to the negative v. As we know, this one is even function. It can be found out very easily. So first one, it is even function. Second part, as we know, because e to the negative 0, whatever, or negative 0 or 0, which is equal to 1. So which means e to the negative v is less than e to the negative 0. As we know, whatever we get for the e to the negative, which is less than 1, which is equal to 1. So which means we can get this one. So this is second part that we need for the autocorrelation function. For the last one, e to the negative v transfer to Fourier transform, which equal to 2 omega divided by omega square plus lambda, 2 lambda divided by lambda square plus omega square. As we know from the lecture, this one is non-negative. So we got three parts for the autocorrelation function. First one, it is even. Second one, this function is less than R0. And its Fourier transfer is non-negative. So which means it is autocorrelation function. For the power spectrum, as we know, we need to find out SW is a power spectrum of WSS process XT, then it is non-negative. As we know from the above part, we already know e to the negative omega, absolutely omega is bigger than 0. So which means it is power spectrum density, power spectrum of the WSS process of XT. So the first part is finished. For the second function, which is Fv equals sine square of v divided by v square. As we know, because it is 2 square, which means it's even function. So the first part we need, it is even function. Second one, same as before, we need to get limit this one close to 0 for this function square. As we know, when we put this 0 in here, almost 0 we can get is 1. So which means this one is less than limit close to 0. So we can get this part. So this is second part we need for the autocorrelation function. Last part, third part, which is Fourier transfer of this one. When we do the Fourier transfer, we can draw out the graph of this part, which is this one. We can directly see the graph for the Fourier transfer. It is non-negative. So we got the three parts we need for the autocorrelation function. It is even, and first one even, got it. Second one smaller or 0, we got it. And the Fourier transfer is non-negative, we got it. So we got 3 parts, so we can prove it is a autocorrelation function of this Fv. For the power spectrum, we can directly get sin square omega divided by omega square, which is bigger than 0. So it is a power spectrum. For the last question, last function, which is Fv equal 1 and O when absolutely V less than alpha bigger than this one. This 2 parts, so we need to use the Fourier transfer formula, like function, to get what is Fourier transfer, because we cannot directly get from the formula that we get before. So which from 1 to -1 and 1 times e to the 2 pi times alpha times omega times d omega. And this part can be equal to -1 divided by 2 pi alpha times omega e to the positive part minus e to the negative part. So this one can be equal to 2 sine alpha times omega divided by omega. So we can directly say that it's non-negative. It's not a non-negative function. So for this part, it is not autocorrelation function. But Fw is bigger than 0. We can directly see it from this part, bigger or equal than 0. So we can get it is a power spectrum.